All right, number 1 on decomposition. All right, again, now, you're going to need to use your Chapter 8 reaction type notes to be able to do this. So, I have number 3 as the example for this one. So, everybody look at number 3 on your decomposition notes. It's the very bottom of the front page. What does it say? What words does it use? All right, stop right there. Can we recognize this is a metal, and I'm going to say metal instead of metallic, but a metal chlorate. Can you recognize that? How? It's a metal and it's a it's a metal and it's a chlorate. That's it. That's how to recognize this. Now, metal chlorates are very special. The way they decompose is something different than you would probably guess. What does it say? Metal chlorates do what? Decompose into. All right, stop right there. So a metal chloride and what? Plus oxygen gas. Now, what is special about oxygen gas? Is it just O? Very good. It's O2. All right, so that's one of the parts that you need. So what I want you to write is what I have in purple so far. Go ahead and write what I have in purple. Or pink, whatever you want to call that. They won't get that. What?
You told us that one. You sent that to us.
I might have. I don't remember. All right. Now, here's the deal. Metal chloride is what we got to have left. First of all, what is our metal? Okay. It's nickel. Nickel is our metal. And it's going to be with what now? Chloride. Now, ide, is it with something or by itself?
What did you say?
Now, but listen, the metal chloride, is that a new compound? Yes. What do you do with new compounds? All right, so we have nickel and we have chloride. I know chloride is a -1 because it's in group 17. Nickel is a transition metal. What do you do with transition metals? All right, so I got to pull this up here. So it's a 2+, right? So 2+. So what's your formula? Very good. NiCl2. What do you do with all reactions? Is it balanced? No, it is not. How do we need to balance it? All right, I have how many NIs on the left? NIs on the right. Hang on. I have 2 Cls. I have 2 Cls. I have how many oxygens? 6, so I need a 3 there. So 1, 1, 3. 1, 1, 3. No. This. All of these are decomposition. All of these are decomposition. These are just decompositions. Okay. All right. So here's what you're going to be worried about, and I'm gonna give you the best news you've probably ever got in this class. I'm feeling generous this year. I've never done this in the past. Okay. Let me see your notes for a second. These notes on your test on Wednesday, I will allow you 1 note card, a 4x6 note card, with as much information you can get on it. With one very, very important clause. Only words. Do you see how it says number 1 under synthesis? It says metal plus oxygen yields metal oxide. That is it. No formulas, no examples, only words. That's it. No, just you have to write metal plus oxygen makes a metal oxide. No formulas.
Can you write like A plus X?
No, nuts formulas.
That's not A plus
So here's the deal. Here's the deal. The test is Wednesday. You turn it into me Tuesday. I'm going to check it, look over it, and if it's good, you'll get it back on the test day on Wednesday. One side.
Oh my God.
You want it at all?
No, yes. Wait, so
That's your deal. You get 1 note card, 4x6, one side, as much information you can get, but it's got to all be words, no formulas. And if I check it and there's formulas, tearing it up. Now listen,
like 90
only
beryllium.
on synthesis and decomposition reactions only, just your first 2 sections. No combustion, no redox, no acid base, no double or single replacement. It's all of it.
All of every single one of them?
Mhm.
And you can only write about 2 of them?
Those two.
Wait, but why? Wait, what? Alright, listen.
That was a quiz. Everything will be on the test. That was just,
Decomposition is what we're learning now.
yeah. It's on. There's special types of decompositions. What I'm saying is, in the past, they had to memorize metal chlorates decompose into metal chlorides and oxygen gas. I'm actually giving you the chance to be able to write the words down so you can be able to do it better on the test. You don't have to memorize it.
I have a question. Is A plus X equals AX?
That's a formula. Yes. Those are formulas. No. All right. Let's look at the next one. Go to number 2. All right. AgO. No, excuse me, Ag2O. All right. What example decomposition number is this? Number 5. Look for number 5. All right. What does it say in number 5?
But you're not going to give us what
No, number 5. Some oxides. Now, what kind of oxide is this one specifically? Is it a metal or a non-metal oxide? Why is it a metal oxide? What is Ag? It's a metal. Ag is silver. Metal oxides, keep reading, decompose into what? The element metal. And what? Only words on your note card. So if it says oxygen gas, you have to write oxygen. If I see O2, if it says water, you write the word water. Do not put H2O.
Can you have like a tutorial?
You have an after school.
How about bring it in Monday, and I'll look at it, and I'll circle what's wrong, and you can fix it.
No, like I'm gonna use like
Let's have a tutorial Monday after school.
That's what I'm doing.
Just in case.
Yeah, that's like number 3. We're not gonna.
No, you've got to figure it out.
That's fine.
This is what I'm teaching.
This is only the second part. I'm not gonna.
Just having a mental breakdown.
I know.
Metal oxides, and it says word for word, metal, an element metal, and oxygen. What is the elemental metal? Ag. And then oxygen is what? That's it.
She's asking for help.
And I got to bounce. But here's the deal. Let me ask you something. Can I take this 2 that's attached to silver and transfer it? Never transfer subscripts. Who does this 2 belong to? It belongs to oxygen. You can't. It's just like you walking into class and saying, hey, I don't have a pencil. Can I borrow your pencil for today? That's not yours. You borrowed it for the time you are sitting together, and then when you leave, give it back to him. Ag left oxygen, so it's no longer his 2. Does that make sense? Okay? Does it really?
Yeah.
All right. Well, I give up on that. Now we got to balance it. I've got 2 AGs, 1 AG, 1 O, 2 O's. So I need a 2 here and a 4 there. So 2, 4, 1. Okay. All right. We're going to skip number 3 and go to number 4. All right. FeOH3. All right. Now, what specific decomposition type is this? This is number 2. All right, so everybody look. This is a metal, and that's a hydroxide. So it's a metal hydroxide. And what does it say in example number 3? Metal hydroxides decompose into what? All right, so a metal oxide and what? And water. Again, on your note card, will you write H2O? No, you'll write the word water. All right. Now, what is our metal for our metal oxide? Iron. Very good. But is a metal oxide a new compound? Yes. So we need Fe. Now when it says oxide, what is it specifically? It's just O, but it's a compound, so what's its charge? 2 negative. What is our charge for iron, and how do you know? How do you know it's a 3? Right there and right there. That's a 1 negative. That's a 3 positive, so I need a 3 plus right here. All right? From there, what do? So we have Fe2O plus water is H2O. Yes, sir. And this one, I'm going to be honest with you, it's easier to do it as H2O. Here's my hint, or here's my suggestion, Charles. The only time you need to write HOH is an acid base. That's really the only time I would ever write it, because it always works. This one makes it a little harder. All right? Now we need to balance it. How can we balance it? I need a 2 in front of Fe. Now I'll do the H's next. How many H's do you have on the left? 6. How many do you have on the right? How can I make it 6? 3, and that balances it. Because 3 plus 3 gives you, on the right gives you the 6 on the left. All right, so do you see how you use your notes in accordance with this sheet? I always save the H's and O's for last. Okay? All right. Now, I'm going to go down to the bottom part, the single replacement one. All right. Look at number 2. Excuse me. Yes, synthesis. I'm sorry, synthesis. Na plus O2. All right. What specific synthesis example is this? Guys, all y'all put your phones up, please. Put the phones up. Okay. What specific example? What number, though? Number 1. This is a metal. We have a metal, and again, this is exactly how you write it on your notes. Metals plus oxygen. What do they come together and make? Very good, a metal oxide. Now, is that a new compound? What do? All right, so Na is in group 1, so it's plus 1. Oxygen is always a 2 negative, so you have Na2. Now, Tyler, in this one, I'll show you what I mean. All right. How can I balance this one? All right, so I need a 2 here, but then I need a 2 here, right? But then what does that do to my sodiums? That stays a 2. I'm sorry. That stays a 2, and that changes to a 4. So you see what I mean? Because 2 and 2 and 2, like, I have 2 oxygens. Now I have 2 oxygens. I have 4 sodiums, and I have 4 sodiums. Okay. All right. So does that make sense? All right. Let's do y'all scratch number 3 off. Let's look at number 4. K2O plus H2O. All right. What specific example synthesis is this? Number 5. What does it say about number 5? Very good. All right, so we have a metal oxide plus water. What does it say it makes? Very good. So we have a metal hydroxide it's got to make. Very good. All right. What is our metal? Juan, you with me? You sure? Am I going too fast? Considering you're getting what out now? Okay. All right. You know. So we have metal is our potassium is our metal. So we need to check our charges. So we have K plus, OH minus. So we just have K, OH. Is it balanced? Nope. How do we balance it? Where? Emily, you with me? Angelique, you with me? You sure? Can you hear me? Thank you. Thank you. Okay. Charles, you good? Does it make sense? Tyler Reddick. You good? All right. You've been talking the whole time. I'm asking the people that hadn't said a word. Corey never says anything, but he makes hundreds on everything. I don't worry about him. All right, go ahead. Go. It's just one of those things. All right, I need you to look at this now. I'm going to stop here and I'm going to let you guys work on it on your own for a second. Everybody look at number 9 at the bottom. All right, I need you to read because this is important. Now, first and foremost, there's 2 parts to this. Number 1, number 9, this is just like number 1. So go back up where it says MgCl2 plus O2. Do you see how 1 and 9 look almost identical? Does that make sense? Okay. All right, so that's part 1. 1 and 9 are the same. But how do you do it? Stop. I know, that's why I'm fixing to explain it. Number 9 and number 1 are the reverse of the decomposition type number 3. So I'm going to explain it. Stop. Just listen to me. Everybody look at decomposition type number 3. What does it say? Metallic chlorates do what? Decompose into metal chlorides plus. Well, look at the reactants in number 9. What is NaCl? That is a metal chloride plus what? So just do it backwards. So what is it going to make? A metallic chlorate. NaClO3. I'm telling you. It's just backwards. So number 1 works the same way. Now read number 5. BaO plus CO2. This is the reverse of decomposition type number 1. So look at type number 1 and just read it backwards. Okay? Because decomposition reactions and synthesis reactions are opposite. So notice, if I read this reaction from left to right, what are you doing? Type-wise. You're taking 2 pieces and what are you doing with them? Putting them together. But what if I read it the opposite way? What if I read from right to left? What are you doing? That's breaking it apart. So what type is it? So do you see how they're one and the same? You can do them both the exact same way. Depends on what way you look at it. So you have to look at what you start with. Does that make sense? Yes, sir. Number 6 is a special type of synthesis. It's in the notes. Look, see if you can find it. Okay? All right. You guys see if you can do the rest of these. I'm going to walk around and help you out. Carbonate is CO3 2 negative.